Good morning. My topic will be dealing with double integration in polar coordinates. To begin with, we require to understand how we can convert from Cartesian coordinates to polar coordinates. X is basically r cos theta, y is given as r sin theta. If you add the square of x and the square of y, you end up getting r square, and the angle theta is given by tan inverse of y by x. This is the conversion we will have to use whilst converting from Cartesian to polar. Similarly, if we consider an integral in Cartesian form, we may be able to convert the integral in Cartesian form to an integral in polar form. Obviously, x and y will be changed in terms of r and theta. Dx dy will change to r dr d theta. So the first question we're going to be dealing with is convert to polar coordinates and evaluate. We have to evaluate integral 0 to infinity e raised to minus of x square plus y square dx dy. Here we see that x runs from 0 to infinity, y also runs from 0 to infinity. You will realize that the region includes the first quadrant. This is the first quadrant that we see here. Now when we convert to polar coordinates, we will see that x square plus y square will simply be r square, dx dy becomes r dr d theta. To chalk out the limits, we will require the limits on r, which are reflected here, as well as the limits on theta, which are reflected here. The question is, how do we get the limits on r? If we go back to the region, we realize that this being the first quadrant, to get the limits on r, from the pole, we shoot an arrow into the region. The red arrow that we see here, we see that this arrow starts at r equal to 0 and extends right out into the first quadrant, and that goes right up to infinity. So you have r going from 0 to infinity. Similarly, we would require to know what is the range of theta. You can consider taking the arrow and placing it along the x-axis. Then sweep the arrow throughout the x-axis right up to the y-axis. That would cover the whole first quadrant. So the question you will ask yourself is, what are the limits on theta? You will see that as long as the red arrow is on the x-axis, theta is equal to 0. As you sweep across the first quadrant and move right up to the y-axis, you will see you're covering a distance from theta equal to 0 right up to theta equal to pi by 2. And that's why we have theta going from 0 to pi by 2. As usual, in our earlier class, we've seen that we will have to work with the inner integral, and this is with respect to r. On making a substitution as r square equal to t, this is the integral that we get out here. On solving this integration, this is what we get. And then we are left with integrating only with respect to theta. And on doing so, the answer we attain is pi by 4. Now, if we need to find the area using polar coordinates, I could find the area of a circle x square plus y square is equal to 9 using polar coordinates. And how is that done? Now, when you see x square plus y square is equal to 9, you will see that r square is equal to 9. That would give us r equal to 3. So, if you consider the whole circle, the red circle that we see here, we see that from this point, I can shoot r from 0 right up to the circumference of the circle. And what is r along the circumference of the circle? R is simply equal to 3 along the circumference of the circle. So you have r going from 0 to 3. And the whole circle covers a theta value right up from 0 to pi, from pi to 2 pi. So you have theta going from 0 to 2 pi. So that's what you have with regards to your limits of integration. R going from 0 to 3, and theta going from 0 to 2 pi. As usual, we perform the inner integration, and the result we get is 9 pi. That will be all for the class. Now we will perform assignments on the same. Thank you.